Today we're going to take a look at damping. What happens to an oscillator when there's some friction in the system?
We get damping whenever there's some friction in our system. So here we've got a vertical oscillator oscillating up and down, but now we've got some friction in the system, and that means our total energy is going to decrease. And since our total energy in a mass spring system is a half k times the amplitude squared, that means that our amplitude must be dropping as well. And you can see that in the diagram. Here's our original amplitude, and then our amplitude becomes this value and then this value, so the amplitude keeps decreasing. What's kind of surprising is that the period is staying fixed. If we look at the time between this peak point and the next peak point, which would be one period, first oscillation takes exactly the same amount of time as the second oscillation, takes the same amount of time as the third oscillation. And that's because you might recall that omega is equal to square root of k over m for a mass spring system, and you notice that there's no amplitude in that equation. That means the amplitude doesn't affect the angular frequency, so of course it can't affect the frequency or the period as well. This situation that we've been talking about is usually referred to as light damping, and that's where you have lots of oscillations still taking place, and it takes a while for the amplitude to die out. This second situation here that's been drawn is called underdamping, and when we refer to it as underdamping, we're thinking of mechanical systems such as shock absorbers, where you'd like a very smooth run. You notice that the oscillation overshoots equilibrium. Here's equilibrium right here, right? It overshoots equilibrium, and that's the key feature of underdamping. So you get a little bit of an oscillation before you reach equilibrium. So you go over a bump, but then you feel another bump because of the oscillation of the shock absorber. What you really want from a shock absorber is what's called critical damping. Key features here. First thing is that there's no overshoot. And the other thing is that this amount of time here, that's the least amount of time it could possibly take to get back to equilibrium. So this is the least amount of time to reach equilibrium. And in fact, if it took more time than that, we call that overdamping. If it was like this situation here, this would be referred to as overdamping. For a shock absorber, we don't want overdamping because it'll make the car seem really stiff when you go over a bump. You don't want underdamping because it's going to feel like you're going over several bumps because of the oscillations. So that's all adjusted by changing the type of fluid that your spring system is in. And you want just the right thickness of oil so that you're going to get this critical damping.
Let's summarize the big ideas from the video. The first idea was that if you have an oscillator with friction, then the amplitude of the oscillator will decrease. And be careful here because the period remains fixed. It doesn't change. And then the amount of damping, the amount of friction, allows us to categorize different scenarios. The first we call light damping, where we get a gradual decrease in the amplitude. The second would be called underdamping, where there is a slight overshoot of equilibrium and then it goes back to equilibrium. So if this is the shock absorber on a car, you're going to get kind of a rough ride because you'll do some extra bouncing when you go over a bump. What we really want in a shock absorber is what's called critical damping, where the amplitude decreases to equilibrium in the minimum time. The fourth option would be what's called overdamping, where it takes a long time for the system to return to equilibrium. And in a car, that's going to give you a very rough ride. So please take the time to like videos, to make comments, to ask questions. become a subscriber, sign up for notifications, become a member or a Patreon.
And that's all for today, folks. Thank you very much.